Good morning, everybody. Here we are back coding on Swiboe, and we were working on actually making Lua kind of sort of work for our key maps. And yesterday we ended in a mess. We had something that was not working, that was crashing, and whatnot. And I continued a little bit tonight and yesterday night, and a little bit this morning. And I think I figured it out. Yes, I did. I think I did. So how does it look? Um, let's look at our configuration file. Right now we have here some magic that I was trying to debug stuff with. We don't need that anymore. And some more magic down here which forces Lua to garbage collect. We don't want that either. And basically what we do is we have the execute function. It gets a client passed into it. Then we have a Lua, like a print call in Lua, and then we call out to the sum function that we wrote in Rust for the thin client, and then we call another function in Lua. And if we see basically this and this, then we know that nothing crashes. And if I indeed run now the terminal GUI, we ignore all the errors, and then I press the A key a couple of times. You can actually see in Lua function called Lua sum function still inside the Lua function. So, ta-da, everything is working. And how did that actually look? How did that look? Yeah, so basically that needs two things, right? First, we need to set up a meta table for our thin client in Lua. So when we bring up the Lua state, we have to register that meta table. And where is it? Here, that's how it looks. It's very simple actually, but there was some secret sauce that we were missing. So first we create a new meta table. This will actually already, that will push an empty table onto the Lua stack, and it will register the table in the registry with this name, right? With this, with this name. And that was some secret sauce that we were missing. We actually have to set the value that is called underscore index in this meta table to the meta table itself. This value is actually used when Lua tries to look up a value in a table, and since this meta table will be associated with our user data, it will also use this table to look up values in our user data. So basically, to find functions on our object, we actually have to register this here. And then we just say where we register the functions into this one, and then we're done. And of course, our functions right now are our the sum function that we actually wrote yesterday. And we added a magic function which is called underscore GC, and this function gets called as soon as Lua garbage collects our one object. Of course, garbage collection doesn't really fit nicely into the Rust memory model, so we have to do a couple of magic things to actually make that work. So let's look basically how we create an object. We had this this push thin client method for that, and that also became rather easy. So there are a couple of tries I did here that didn't quite work. Yeah, so basically all we do is now we set up the Lua state, and then we create a new user data object, which is just a slab of empty memory that Lua allocates for us and returns a pointer to. And then we move the thin client that this function gets passed to, we move that into this one object. Just copy it over, right? And actually this move already makes sure that this object is no longer usable after the fact. So basically here we transfer ownership to Lua. But we still have to make sure that there is actually garbage collection taking place. And the way to do that is to implement this underscore garbage collection method, like here. Actually, that's no longer true. We did that already. And that looks also very simple. Basically, all we do is like we get a Lua state pointer, so we turn that into a like unowned state. And then we check that at the top of the stack we actually have a Swiboe thin client object. Otherwise, this will actually return with a Lua error. So all good. And then we drop this thin client, which basically will tell Lua Rust to run all of the destruction except for releasing the memory. And that's all that is needed. And then we return again, and Lua will free the memory pointer. So I think we're good. I think like we probably did everything that we needed. And of course, our sum function should not be called sum function, right? What we want to do in the end is we want to do something like this RPC call here, right? We want to, basically when you press the button, we would like this to happen. Basically, you use the client to call to the, we use the client to call to GUI buffer view move cursor, and I get some parameter, which is in this case only the delta lines, and this should return an RPC, and then we wait till the RPC terminates and we're done, right? That is what we actually want to happen in this function call. So let's start by renaming some function to actually call, right? And let's look at the parameters for call. So this one is easy, right? That is just a string. We can easily convert a string to something from Lua into Rust. This one is more tricky though, because we get a Lua table that contains keys and values, but we actually need a JSON object because all the RPCs take JSON as parameters. So we have to have a general conversion from Lua into JSON. And I think there are two ways we can go about it. So like first we could find us a Lua library that actually converts from Lua tables into JSON and drop that in, or we write our Lua to JSON converter ourselves. And eventually I think we actually want to write our own Lua to JSON converter. But to make rapid progress, I'm just looking now for a Lua to JSON library, ideally written in pure Lua, so that we can just like dump the contents into this file and make progress. So JSON Lua, and look at that. regex.info says block Lua JSON, simple JSON decoding in pure Lua. And unfortunately, oh, it's a Creative Commons Attribution 3.0 unported license. I'm not quite sure what that means actually, but for now that will be fine. Maybe I cannot check that into the repository. But thanks so much for providing that, Jeffrey Friedel. Shout out to you. That will help us to make rapid progress here. So we just go ahead and we dump the full file here. Wow. And what does it say? Like, it seems like somehow the syntax is messed up. Ooh, that's a lot of code. It expected a end of file. Why does it expect an end of file? Oh, because there's a return statement here. So this is not working. I cannot just dump it here. So I have to probably dump it into a separate file, json.lua, and then maybe I can require it. Does that work? How does that work? Oh, I wish I knew Lua. Require JSON. Modal JSON not found, it says. Oh, that's how you use it. Okay. Like so. Wonderful. Now it complains no longer about the syntax and it actually is able to load that. And then we call JSON encode Lua table or value. So basically here in our function we say the args is actually, it's not let, it's local, and the args is JSON encode. Pretty, yes please. And basically we want this table. Like so, right? And let's print that and see how it looks. And what does it say? That looks right. That looks perfectly right. Okay, let's add a to-do here. Let's make it a no-com. Need to implement our own Lua table to JSON converter eventually, but using a Lua library now makes that faster. And then here, what do? We just basically we call out to the client, to the function, which is it's down here. So we just use this. Basically, we say client call this with those arguments. Nice. And we add another no-com here. This should return an RPC object, but for now we just implicitly wait. And now we need to, the Lua sum function, we actually rename to call. And in here, oh, we're nearly done. Wow. What do we do in here? We call thin client call, and I don't remember how call is actually looking. Thin client is, in which file is that? I think it's in client mod, right? Yes, there it is. And where's call? Here's call. So what does it take? It takes a function name and it takes arguments, and arguments simply have to be a serializable object. So what we need basically is here we need a let function name will be state check string. Does it exist? Yes. What does it do? It returns a string. Cool. Very simple. So check string should be the second argument, and then we have the JSON arguments as string, and this will actually be the third argument. That should work. And now we have to let JSON just call them args, and that will be serde JSON from string JSON arguments as string, and we actually we unwrap, right? We are super brutal about that. That means basically that the program will crash if this is not valid argument. Should not crash if JSON arguments is malformed. And then we call thin client call. That will give us a mutable RPC object back, I think. and that takes the function name, and it actually, I think it, yeah, it takes a reference to the arguments. And that returns us a client context, and on this one we just wait. And here we should say no-com return failure information to Lua, right? And let's see if that compiles. So it doesn't like certed JSON is missing, so extern create will be certed JSON. Unable to infer enough type information about underscore, it says. And I guess that is true. I have to tell it that we actually want a certed JSON value object. Okay. Cannot borrow state as mutable more than once at a time, it says in 74. What? What? Previous borrow of state occurs here. The mutable borrow prevents subsequent moves, borrows, or modification. So basically, here we call the check user data typed, and that will actually, I guess that is correct, right? It will actually borrow the state. How does that function look? Check user data typed. Yeah, that's bullshit. That's really not correct here. Basically what it says is it takes a reference to a state that lives exactly as long as the value that we actually return. And while that is technically correct, it will also mean that nobody else can use the state in the meantime mutably. And that's unfortunate here. But all that it means is that we actually move those two checks before that, right? Basically what we do now is like, when do we use the state? So here we create the state, or yeah, now it should work. Basically, we first call the two check strings, which will not borrow the state, so they will just use the state and then return it again. And then this actually will eat the state and keep it occupied until this thin client is destroyed again. And that way it should work. Oh yeah, perfect. Perfect. So, great. Now we can see that we can't see anything. Of course, because probably it is calling out to this method, but there is no buffer open, so we cannot see that. But I guess if I open a file, for example, config.lua, and now if I press A, nothing happens. Great. Okay, now let's try with one of the core functions. And one of the the most core function is core exit. So let's do that. Basically, we call core exit, and what should happen is that if I press A now, our server should exit, right? The server is running here in the background all the time. If I now press A, it should exit, and something happened. It says send error. Well, what do you know? Send error. But at least something happened. And now, of course, I cannot exit the client anymore because the client cannot talk to the server anymore. And yeah, well, let's kill our terminal GUI here. Quit. Okay, let's try it again. I'm really interested what happens here. So I run the terminal GUI, and now I press A. And what happened? Nothing. But now it crashed again. Interesting. Interesting. Well, that's another bug to look at, but like what we can conclude from that is that it's actually working. We can call a RPC, so we're good. We're good. We're good. But we actually, I mean, next time we want to try to actually use those buffer view move cursor arguments, and I think one problem that we have there is that we actually don't know which cursor ID we need to move. So maybe there was that, and yeah, I'm actually not sure if I now open a file, config.lua, if I actually, oh yeah, like cursor movement is not working at all. So maybe it's also that. Okay. I mean, I was trying the cursor keys right now. They used to work, but we might have broken them when we introduced the key maps. But yeah, I think I'll stop here for today. We actually made some progress. We actually are able to call RPCs now from Lua. Unfortunately, we actually have to we have to pass in a full Lua object, not Lua object, like a full JSON string to this client call, and it would be much better if you could just pass a table. For that, we actually still we rely on this JSON.lua file. I will now figure out if I'm able to actually check that into the repository from the license point of view. If that is possible, then I will make this a CL and actually suggest it for merging. And the next time we can actually look how we can make this GUI buffer move cursor work if we have a file open. Okay, thanks for watching. As always, remember Swiboe is a community project and I would really appreciate contributions. So if you feel like helping out, there's a lot of stuff you could work on. For example, you could write this JSON Lua table to JSON converter in Rust, or you could actually look into the key mapping, which is very janky right now. There was a good suggestion yesterday on Reddit that I really liked and I opened the bug for, which suggested that not only should the key mapping support arpeggios and chords, it should also support long presses for keys. And that's such a good idea. I really like that, but I have no idea how that can be implemented right now. For example, I don't know if Rustbox actually gives you key up and key down events, which would be necessary to do like timing of how long a key has been pressed. But if that is possible, that would be really an awesome contribution. And yeah, also you could look into returning an RPC from the client call, like from this call down here. And then we could do interesting stuff in Lua too, for example, wait for an RPC or cancel a streaming RPC and so on. And then we are more than halfway to a Lua client, like a Lua plugin client, which we could pull out and actually make a standalone thingy for, like a standalone plugin for Swiboe. And that would be awesome. Okay, yeah, talk to you guys tomorrow.